Good afternoon, geometry students. We are now in section 5-4, and we are going to be working on something called medians, altitudes, and angle bisectors. So we're still just working in triangles, but we are going to be drawing some additional lines in them, and these additional lines are going to have properties, and then we can use those properties to solve problems. So let's talk about these three new pieces of, these three new definitions, and then we'll be able to implement what we know about them. So, first of all, what is a median of a triangle? A median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So a median is a segment whose endpoints are a vertex and the midpoint of the opposite side. So in this image, BD would be beginning at the vertex B, and then coming down here, and if D is at the very center, then that would be considered the midpoint, so that would be a median. I'm going to draw an image for you just so you can kind of see what it would look like in another triangle. So let's say that this is our triangle, and I have to start at a vertex, and the vertex is going to go to the midpoint of the opposite side. So down here is the opposite side, and I have to connect it to the center. I think about there looks like the center. So then I connect the 2 points just to mark that those guys are congruent. This guy right here would be the median. Notice it's connecting a vertex and a midpoint. So those are the two things that it connects in order to be a median. Okay, our next piece of vocabulary is an altitude. What is the altitude of a triangle? The altitude of a triangle is a perpendicular segment of a side of a triangle connecting to the opposite vertex. So once again, it's going through a vertex, but now instead of it going through the middle of the side, it needs to be perpendicular to the side. Now, if you don't remember what perpendicular means, that means 90 degrees. So I'm just going to mark that as 90 degrees just to remind you. So I'm going to draw an image again so you can see what that would look like. So here we have a triangle. I'm going to start from this vertex right here, and it needs to be perpendicular to the opposite side. So right here, this guy would be perpendicular. Notice this is no longer in the middle. This side is clearly longer than this one, but this intersection is special because it's perpendicular or 90 degrees. So this orange line would be the altitude. And actually, let me label that in both of these. So this one is the median. This one is the altitude. Finally, we have an angle bisector. An angle bisector, we've already talked about these, but we'll define it again. It is a segment that bisects an angle and connects to the opposite side. So don't forget that the word bisect means to cut in half perfectly. So if I were to draw my triangle this time, I'm trying to draw them relatively similarly so you can see the differences between them. I'm going to start at this angle, but this angle needs to be bisected. So I'm going to do my best to make it look like this angle is cut in half. Okay, yeah, that looks pretty close to half. So that means this part and this part are congruent, and then it just goes to the opposite side. So this guy right here would be the angle bisector. Okay, so just to summarize, median goes from a corner to the middle of the opposite side. Altitude goes from the corner perpendicularly to the other side. Angle bisector goes from the corner by cutting it in half, and then it just goes to the opposite side. So we're going to use these definitions to help us solve the next problems. In example 1, it says, given AD is a median. So right off the bat, we know that we have to have a triangle because we need a triangle to have a median. So what I'm going to do, I'm going to go ahead and just start drawing an image. It doesn't really matter what it looks like as long as you have it labeled correctly. And that's just based off of reading closely. So it says AD is the median. And then it says what AD is equal to, what CD is equal to, and what BD is equal to. So I think that A is going to be up here and D is going to be down here because notice these two segments involve D as an endpoint as well. So I would think maybe this segment and this segment could be those other endpoints. All right. So I'm just going to start labeling, and let's remind ourselves of what AD is. So it's a median, which means it's going to be in the midpoint of the opposite side. So now I know, because it's a midpoint, that this guy and this guy are congruent because D is at the middle. All right. The measure from A to D is 2x plus 19. And then it says CD is 4x plus 1. I don't have a C on here yet, so I'm just going to put C right here. So CD is going to be 4x plus 1. And then DB, I'll just put it here, is 5x minus 7. So the hard part is kind of piecing together the picture, and you just have to kind of take all of your information and figure out an image to where all of the information is cohesive. So anytime it says D, we know we're referring to the same D. Anytime it says A, we know we're referring to the same A every time. So we just have to get all of these to be true, consistent, without contradicting each other, and like I said, cohesive. It wants us to find AD. It wants us to calculate this segment right here. The issue is, how do I do that? Well, while we're looking at our image, we want to look for things that are congruent or things that are in relationships that I can easily define. Notice how this half is congruent to this half. The reason I know that is because D is a midpoint, so the two halves have to be the same. Because they're the same, I can set them equal to each other. So I'm going to say 4x plus 1 is equal to 5x minus 7. Now I'm able to get somewhere. Once you get an equation written down, you're in pretty good shape. So I'm going to subtract 4x from both sides. That gets me 1 is equal to x minus 7. Then I'm going to add 7 to both sides, and I get 8 is equal to x. Okay. This is just a middle step. I'm not looking for x. I need to find AD. So I'm now going to take this x equals 8 and substitute it in to my value. So I'm going to say 2 times 8 plus 19. That is 16 plus 19. 16 plus 19 is going to be 35. So I'm going to say 35 is equal to AD. So all I did in this problem was I used the definition of a median, and it says that a median connects the vertex to a midpoint. Because this is a midpoint, it's cut perfectly in half. So then I used that to set these two guys equal to each other, and then I substituted in from there. Okay, moving on to the next example. Example 2 says AD is an angle bisector. We want to find the measure of angle B. So we need to organize our image first. Because we have an angle bisector, I know I'm going to need an angle. So I'm just going to start drawing an angle. I'm going to go ahead and draw a triangle. It says AD is an angle bisector. So I'm going to bisect this angle just so it's easy. Well, if I can draw it in the right spot. Okay. And I'm going to say that this half is congruent to that half. I know that because it's an angle bisector. And I'm going to label it AD because it's this segment right here. It says the measure of angle CAB is equal to 72. Okay. I don't have many options for where I can put my letters. I have a C and I have a B. I cannot put them in the same spots that I already have. So I'm going to have to say right here and right here. So now I know that this whole angle across from C to A to B, the whole thing is going to be 72 degrees. Then it says the measure of angle BAD is equal to 6x plus 18. So B to A to D, that is this half of the angle. This part right here is going to equal 6x plus 18. Then it says the measure of angle B, well that's down here, is 7x. Okay, it wants us to find the measure of angle B. We have a few relationships that we can easily use. Notice how this is an angle bisector, and remember, a bisector cuts something in half perfectly. Bisect means to cut in half, not just to cut in two, but to cut into two equal pieces. So that means that this half of the angle is the same as this half of the angle. I can figure out what this half is by taking the total 72 and dividing it by 2. So 72 divided by 2 is going to equal 36. That then means that half of the angle is 36. But I also know that half of the angle is 6x plus 18, so I can set them equal to each other to solve for x. So now I'm going to say 36 is equal to 6x plus 18. Then I'm going to start solving. So I'm going to subtract 18 from both sides. That gets me 18. Then I'm going to divide by 6, and I get x is equal to 3. Awesome. I am 2/3 of the way there. I have x is equal to 3, but remember, I don't want to solve for x. I want to solve for the measure of angle B. This is what I'm trying to find. Well, the measure of angle B is equal to 7x. So what I can do is I can take 7 times 3, which is going to equal 21 degrees, which is equal to the measure of angle B. I just took my x equals 3, and I substituted it in for x, and then I multiplied them together because it was just 7 times x. Okay, one more problem. This time it is with an altitude. So let's repeat our vocab one more time. A median connects a vertex to the middle of the other side. An altitude connects a vertex perpendicularly to the other side. And an angle bisector connects the vertex and the opposite side while the angle's being bisected. We want altitude for this one because in our problem it said AD is an altitude. So I now know that it's going to connect a vertex perpendicularly to the opposite side. So I'm going to draw an image again. And like I said, it doesn't matter what your triangle looks like, just as long as you can see it and it's neat and it doesn't contradict any of the problems. So you have to follow the directions in the words, but as long as it's meeting these requirements, your image is fine. So here's my triangle, and AD is an altitude. Okay. So it has to be at a 90-degree angle to one of the sides, and I'm going to label it AD. It says the measure of angle BAD is equal to 3x minus 2. So I'm just going to label this one B just because. And it says BAD is equal to 3x minus 2. So that is this guy right here. This one is equal to 3x minus 2. And then it says measure of angle ABD, this guy, is equal to 5x. Now the way I know what angle it's talking about is because remember, the letter in the middle is the vertex of that angle. So because A is at the middle of this one, then my angle is at the vertex A. Okay, I am going to need to find the measure of each angle in triangle DAB. Okay, so I need B, I need D, and I need this angle up here. Well, if we want, we can just start with what's easy, because we can easily find the measure of angle BDA. Because this angle right here is 90 degrees, then we know this one here is also 90 degrees. So let's just go ahead and write that down, because if you don't know where to begin, just start with what you know. So I know the measure of angle BDA is equal to 90 degrees. So that's one of my answers. This guy right here is 90 degrees. The reason I know that is because it's an altitude. Okay, after that, I need to find a relationship in this image that I know so that I can set up an equation. Well, remember that the angles in a triangle add to 180 degrees. So if I focus in on this triangle right here, I can say, oh, those angles add up to 180 degrees. So what I'm going to do, I'm going to say 5x plus 3x minus 2 plus 90 equals 180. So that's getting me an equation. And like I said, when you get an equation, then you're typically doing much better. You're on the right track if you can get an equation. So now let's start solving. I'm going to subtract 90 from both sides just to make life easier. So now, and I'm also going to combine these two guys. So I have 8x minus 2 is equal to 90. I'm going to add 2 to both sides. Now I have 8x is equal to 92. Then I'm going to divide by 8, and I get x is equal to, if you put that into your calculator, then you should get 11.5. All right. I now know what x is equal to, but I don't want to stop there. I'm going to do the same thing that I've been doing each time. I'm going to take this 11.5 and I'm going to substitute it in for each value. So for B, it's going to be 5 times 11.5, which is going to equal 57.5. Just put that in your calculator. So now I know the measure of angle B is equal to 57.5 degrees. I can take this 11.5 and substitute it in again to figure out this angle. So I have 3 times 11.5 minus 2. Put that in your calculator, and when you do, you end up getting 32.5. So now I know that the measure of BAD is equal to 32.5 degrees, and I'm done. All right, that is all for today's notes. I hope you have a great night, and I'll see you later.